What makes some inventions cost more than entire cities? Is it the rare materials, the years of research, or the dream of changing how humans live? In today's video, we're exploring the top 8 most expensive tech inventions in the world. Creations so bold that price tags in the billions almost seem normal. These are not just gadgets or machines, they are turning points in human history. From rockets heading to Mars to reactors that can power the planet forever, each invention proves one thing: progress doesn't come cheap. Stay till the end, because number 1 will truly amaze you. Alright, let's jump in. Number 8. National Scale AI Supercomputer and Quantum Lab Campus. Let's begin with raw brainpower. Picture a data center the size of an arena, packed with racks of cutting-edge accelerators linked by lightning-fast networks, cooled by rivers of chilled water. Close by sits a cluster of quantum labs with dilution fridges near absolute zero. The bill for one full stack like this can hit many hundreds of millions and push toward $1 billion plus once land, power, fiber backbones, and staffing join the tab. Why is it so costly? Training frontier models calls for tens of thousands of top-tier chips, miles of optical links, and fault-tolerant storage that streams data at surreal speed. Power draw rivals a small town. Then add quantum gear, ultra-clean rooms, cryogenic systems, shielding, and precision control. The result is a 2-engine platform: classic computer for scale, quantum for special problems like simulation and cryptography R&D. It is not a single box on a cart. It is a campus that turns electricity into insight. What does this change for daily life? Smarter medical imaging, safer logistics, language tools that feel natural, materials found in simulation first, then built in the lab. The price looks wild, until the first set of breakthroughs pays it forward. Number 7. EUV Chip Manufacturing Fab. Next up, the EUV Semiconductor Fabrication Plant, the beating heart of the digital world. Building one state-of-the-art chip factory today costs around $20 billion. Inside these facilities, chips are printed using extreme ultraviolet light so precise it carves patterns just a few atoms wide. Each EUV scanner alone can cost over $150 million, and dozens are needed for full-scale production. Every speck of dust can ruin a chip, so the air inside is filtered thousands of times per minute, and workers wear full cleanroom suits. Robots glide silently, carrying silicon wafers worth more than gold. From your smartphone to supercomputers, they all start here, in rooms cleaner than surgery, powered by $20 billion worth of precision. Number 6. B-21 Raider Stealth Bomber. Here comes a silent shadow shaped by physics and signal math. The B-21 Raider represents a new class of long-range stealth aircraft with a unit cost reported in the hundreds of millions, often cited around $550 million per plane before add-ons and support. The airframe looks simple, smooth curves, few seams, but the cost reflects a world of secrets inside: radar low profiles, secure links, sensor fusion, and materials that shrug off heat and stress. Why pour so much into one airframe? Reach, precision, and deterrence. The craft slips through dense defenses, maps targets with refined sensors, and links with fleets in real time. The skin, the angles, the coatings, and the thermal footprint all work together. Maintenance needs special bays. Software needs constant tuning. Pilots train in sims that mirror the aircraft down to switch feel. It is expensive because it compresses many toolkits, propulsion, avionics, data, and stealth, into one package with a mission few platforms can touch. The price buys a strategic option, and that option reshapes planning far beyond any runway. Number 5. James Webb-class Space Telescope. Next, tilt the mirror to deep time. A next-gen infrared space telescope in the class of James Webb carries a total program cost in the multi-billion range when you include decades of design, the segmented mirror, the fold-out sunshield, the launch, and years of operations. The point is simple and bold: look so far that light started its trip before humans wrote words. Why the price? The telescope rides folded inside a fairing, then unfurls into a precision structure among the stars. The mirror segments align to fractions of a wavelength. Instruments chill to cryogenic temps. The shield blocks heat from the sun, earth, and the craft itself. One glitch could end the show, so testing stacks on testing. And the payoff? Images and spectra from the first galaxies, water and organic fingerprints in exoplanet skies, dusty nurseries where suns ignite. A scope like this turns space into a lab bench and time into data. Number 4. Large Hadron Collider and High Luminosity Upgrade. Now dive under the fields near Geneva. The LHC is a ring of superconducting magnets that sling protons to near-light speed, then smash them to reveal building blocks of nature. The original ring and its experiments ran into the multibillion zone. The high luminosity upgrade adds stronger optics, fresh detectors, and new cryo muscle. Again, a big price tag spread across partners and years. Why spend so much to break tiny things? Because the rules we live by sit in that debris. The Higgs field turned from math into measured fact along this ring. Upgrades push the collision count way up, so rare events stand out from the spray. The magnets use superconductors that sit at chilly temps with precision power control. Caverns hold detectors taller than houses. Data streams flow into farms that sort bits like gold dust. This is pure curiosity with strict methods. The cost pays for tools that turn questions into plots, and plots into the next set of questions. Number 3, 100 megawatt fusion reactor prototype. Now picture a star in a bottle. A 100 megawatts fusion reactor prototype can land around $2 billion through design, materials, cryo systems, gyrotrons, and a maze of control loops. Different paths exist: tokamak, stellarator, laser drivers. But the dream is the same: light nuclei fuse and release huge energy, with no long-lived waste from the core process and fuel from common isotopes. Why does the budget surge? Because the device must confine plasma hotter than the sun for long enough to produce net gain. Magnets bend charged particles in tight loops. Walls face neutron storms and must endure. Cooling loops pull heat into turbines. Then the whole thing needs safety studies, power links, and long test runs. If fusion scales, the world gets a firm base for clean baseload power. That single line explains the giant price. It is a stone dropped in the pond whose ripples touch cities, farms, and coasts for generations. Number 2, SpaceX Starship Deep Space System. Time to step off the pad. Starship aims to make giant payloads routine, from satellites to landers to cargo for long trips. Public figures often place the program in the multibillion range, with $3 billion quoted in round terms for stages of development and testing. The rocket is stainless steel, fully reusable, and built for many flights with rapid turnaround. Why is this such a huge lift? Pun intended. Engines in clusters, methane fuel systems, heat tiles across a vast belly, guidance that rides hypersonic flow, and ground support that refills stages on fast cycles. The plan reaches past low orbit toward lunar missions and deep space logistics. A large payload bay turns one launch into a platform for many jobs. If rapid reuse clicks, space gets the scale jump that aircraft brought to air travel. Prices trend down. Flight rate trends up. Science, telecom, and construction in orbit all gain room to grow. Number 1, International Space Station. And now, the one that tops them all, the International Space Station, or ISS. With an estimated total cost of around $150 billion, it's officially the most expensive human-made object in history. A collaboration between NASA, Roscosmos, JAXA, ESA, and other global partners. The ISS orbits Earth at 17,000 miles per hour, serving as a floating laboratory in space. The price includes everything: designing, building, launching, assembling modules in orbit, and keeping astronauts alive for more than 2 decades. Every piece was flown up separately and connected like a cosmic puzzle. Inside, astronauts study everything from growing food in zero gravity to the long-term effects of space on the human body. The station has hosted hundreds of experiments that benefit life back on Earth, from new materials to medical breakthroughs. It's more than technology, it's teamwork on a planetary scale. The ISS proves that when nations cooperate, even the sky isn't the limit, though it sure comes with a $150 billion bill. So, which invention blew your mind the most? The station that floats above Earth like a science city? The collider that cracks open the secrets of the universe? Or maybe that rocket built to carry us beyond the moon? Tell me your pick in the comments, and while you're there, share one wild tech idea you'd love to see become real. Maybe it's a home-sized fusion plant or an AI that can build cities from scratch. Let's dream big together. If you enjoyed this journey through the world's most expensive tech, give it a like, share it with your friends, and subscribe so you don't miss the next deep dive into the future of innovation. Thanks for watching.